Okay. So previous slide we discussed about demultiplexer and MAMSE comparator, and here we are going to discuss about decoders. So how the decoders. Uh, so decoder is similar to demultiplexer, but without any data input. So decoder is similar to demultiplexing. What is demultiplexing? Is one input, several output. So demultiplexing. So, but here there is no data input. So n bit binary. So n bit binary input data, and 2 power n is output lines. A decoder. So decoder is 2 power n for encoder. You know that 2 power n input lines, output is n binary data. Similarly, n binary data, 2 power n is output line. So if you consider if it is 3 input line, then 2 power n is 8. So if it is 2 input line, then output line is 4. So similarly, I have used n input data and 2 power n output lines. So most digital systems require decoding of the data. So application of decoder is digital display, digital analog converter, and memory addressing. 3 is to 8 decoder. So n input lines, 2 power n output lines. So here 3 means the n is nothing but 2 power 3 is 8. So 3 power 3 is to 8 decoder. So see this. So input line is A, B, C. So input line. So 3 input and 8 output. So 0 to 7. If it is 0, 0, 0, then the D0 will be get it 1. Then 0, 0, 1 means then D1 will get it 1. So similarly same. You see this. So that. So whenever it is 0, so it is 1. It's 0, 0, 1 means so D1 will get it output. So similarly, like the Dmax. So this is a 3 input. So here there is no select lines. So we are directly given input. There is a select line. So use select line, we got the output. Here there is no select line. So that's why without any data input. That means input is there, but data input is not there. So D is not there. So instead of D, they are using just ordinary input 3 to 8 decoder. This is logical expression for 3 to 8 decoder. So 0, 0, 0, 0, 0, 0, 1 like that. For D0, D1, D2, D3, it's logical expression. And this is the diagram for decoder. So input is A, B, C. So we can get it 0, 0, 0, 0, 0, 0, 1. So this is basic logic diagram for 3 is to 8 decoder. And 4 is to 16 decoder. So n is input 4 on 2 power n, then 2 power 4, totally 16 output. So here you see A, B, C, D, E. So this is binary input. So based on that, the decoder value is changed. So A, B, C, D, the value of a decoder. So digital decimal digits they return. So the data 0 to 15. So there it is different. So other places are same. So previously we have ones. Here also it is 0. So 4 is to 16 decoder. So this is IC 74154. So 4 input. So A, B, C, D. So 4 input is there, and 16, that means 0 to 15 output is there, and data and strobe. So this is 4 is to 16 decoder IC 74154. So logic diagram for so decoder. 16 4:16 decoder. Okay. Actually, this is the one is BCD to decimal decoder. So BCD to decimal decoder IC number is IC7445. So the 8 they have ground and the 16 they have power supply. So remaining things are the output lines and input get it from 15 to 21. So this is input lines. Okay, and BCD to 7 segment decoder. And this one is interesting part. BCD to 7 segment display. You know that LED display. So see that. So there are 7 segment, one, 2, 3, 4, 5, 6, then 7th one. So every numbers display it will be like that. So design of BCD. So BCD inputs are here. Then a 7 segment output. So this is BCD to 7 segment display. There are 4 input. So if you use BCD to 7 segment decoder, input and 7 segment output. Okay, so 000. So whether it is uh, the BCD means is 0 to 9 only it is possible. Whether it is 0, the 0 wherever the 0 will be blinking A B C D E F. There only you will be get it number 1. So similarly you have the truth table like that. So based on the truth table for A B C D up to G, we can get it values. So based on the values we can do the K-map. A for because of implementation of K-map we will get it that um, Boolean expression. So similarly you will be get it Boolean expression for here every K-map for C D up to K. Okay. F and G up to G you will be get it a K-map and expression, and finally based on the expression you will be get the logic diagram. Okay. Next one is encoder. Encoder it's a combination of circuit and reverse operation of decoder. So it has a maximum input line is 2 power n. Then output is n output lines. So encoder, 2 power n maximum input and n output lines. So maximum input is encoder side, minimum outputs are in output line. So 2 power n input lines, n bit is output line. So 4 to 2 encoder. So this is a black diagram for 4 to encoder logic diagrams. So there's a truth table for input 4 to 2. So 4 inputs 0 0 0 0 1 0 like that. So there are two outputs 0 0 0 1 1 0 1 1. So based on that the input is varying. Okay. So Boolean function for a1 and a0. So a1 y3 plus y2, then a0 actually y3 plus y2. You can get it from K-map. Implement the K-map, you get the Boolean expression. So y3 and y2 and y3 y1. You can draw the logic diagram for 4 to 2 encoder. So a1 a0 y1 y2 and y3. So this is octal to binary encoder. So octal means 8 input. So 2 power n. So that is 8. Then n value is here. That is 3 octal to binary encoder. So similarly here also we having the same that encoder having. See this. See the outputs. This will be like that. So 0 to 7. So expression for encoder, logic diagram for a encoder, and drawback of encoder. This is ambiguity equal to zero. See, there is an example for y3, y6, and y7, and triple one. Um, the corresponding is y6 is equal to 1. So drawback of encoder. To overcome this difficulty, we should assign the priority to each input encoder. So then the output of encoder will be the binary code corresponding to the active high inputs which has higher priority. The encoder will be getting priority encoder. So the having all the inputs of encoder is equal to 0 because it could be code corresponding to the input when only the least significant input is one of when all the inputs are 0. For example, if both y3 and y6 are 1, the encode produce triple one at the output. So the correspondent y3 when it is 1, then not equivalent to correspondent y6 when it is 1. So we have to overcome this difficulty, assign the priorities to the output encoder. So the priority encoder. Okay, so we'll see next video.